So if you look at, this is the input JSON, right? This, the whole thing represent a concept called a post, represent a concept called post. So when you think about this, is that you need to design a class called post, and which the within the class post, every member of the post should reflect an element in the area I just highlight with the JSON. Should be a one-to-one. They should be exactly matching. So this is the, for example, this is a design I provide you in the reference implementation. And this is a class post, and the only difference is right now I changed this to JV time in your reference implementation, because it's better. Instead of using struct, I just use the JSON value time. So you can see that every single one of this member, this is a member, should map with the information that you actually see from the JSON, that which represent a post. So this is the highest level class that you should first design. It's called class post. And then from each of the elements, you start to design other elements. For example, link, action, reaction, and comments. It has to be a one-to-one match in order for you to be able to represent all the information in this particular input, right? That's the high level input. So essentially what you think about, you're doing two things. So if I understand your question correctly, the number one is that, well, how do we start in designing the class? We're supposed to do that. My answer to that is we do it from the highest level and try to match at the first level of JSON key value pair. And then we actually divide the problem into, okay, this part of JSON is actually belong to this particular class. I need to continue design. For example, the from JSON, which represent who is the author, and now I'm actually linked to the person class, right? So from the post class, I actually chop out each pieces within the JSON, and then I need to think about whether I need to design furthermore. For example, the most complicated one is probably comments. If you think about this, comment is from all the way from here to here. This is all, the whole region is about the comments. And so the comments actually including subclass. So you need to have a comment class. And then within the comment class, you have a reaction class. You also need person class. So you can reuse the design. Now you have a person, you have a message, you have a bunch of other things. So essentially you're from the highest level, and then you start to design each to match such that all the classes you define will be capture all the information you need to capture within the whole thing. Okay, that's the one level problem about design. Okay, the second question you have is that, well, how do I actually, once I design these classes, how do I put the code, sorry, not put the code, put the element in the JSON file into this class, right? So that become, you need to write a program, which in my case, I call it HW5 produce, but you can actually call it whatever name you want, but you can just write a program and use that program to start to, number one, to create a post object. And then you're actually going to parse the JSON using the JSON, the interface, to actually start to extract element after element out of that JSON. And for each of the element you get it out, then you basically create using the one of the class you create, because remember, every element you already have a class. So you extract one element, and then you get the corresponding class and create an object, construct an object for that part of the element you just take it out. So I'm going to show you an example what element at the first level of element you will have. Okay, so you know what we're talking about. Let me actually go to, let me use this one. Okay, let me copy again so we can have a clean shot here. Okay, let me make everything black. Okay, so this is the whole JSON. Let's look at how many elements we have. The first, so when I say element, I really means key value pair, and specifically I talk about key. So the first key is, the first level key is ID. Let me use the color red. The second key is from. The third key is to. The fourth key is message. And then the fifth key is links. And then the fifth key is action. Let me see, action. What's the next one? Okay, the next one is created time. And then the next one is update time. This is all first level. If you use a style string, you will see the same thing. I will show you what the style string looks like. And then you have reaction.
How would I access these keys from C++?
I will show you.
Okay, thank you.
And then the next one is comments. And then the last one is published. This is all first level key that you have. Okay, so these are the first level key because you have a recursively, you need to move to the next level. But we have, let me count, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I have 11 classes. Okay, so now I'm going to show you the style string. Okay, so if I do this, I use the parse again, parse. Okay, I go to BBB0. If I go to BBB0, they actually have this. You see now they have a level. They kind of put this level. So let's count the first level. The first level action is 1 key. Comment is 1 key. I mean, these are 11 key, but they're 11 key alphabetic order. Okay, in the style string. So 1, 2. Comment is the most complicated. 1, 1, 2, 3. Created time. 4 from. 5, fifth ID. 6 is published. Link. 7, is that right? 7. 8, message. 9, reaction. 10, 2.
So are all these supposed to be the different classes we have to have?
11, update time. Not necessarily. because if you look at this information, let me show this again. Action should be one class. I mean, in my opinion, you can reuse this action. I actually designed to be, in fact, I have a class which has, I call action. This is actions. The way I design, if you look at the reference implementation, I actually, in the post, I have a vector of action, single. And each of the action has this 5 attribute, 5 variable, okay? And comment is another class I designed. That's why if you look at the reference implementation, you can see how I map this one-to-one. Comment is one, but inside comment, I have a reaction, right? But I also have a reaction for the post. I have a reaction for the comment, I have a reaction for a post, and I just declare one reaction class, and I use for both places. And of
So,
course, created time and update time, they're using the same class called JV time.
so if we wanted to make a class, would we have to make the class in a separate CPP file with a different header, or can we include all classes in one CPP file?
I prefer we make individual .h and CPP file.
So like overall, we would have 4 class files and 4 header files for each class.
It probably, every class you will have a one .h file, one CPP file. I mean, for example, the reference implementation that I distribute today that has, let me show you how many. If you look at this, I have 10 different .h file. Represent posts, represent person, represent reaction, tag, message, action, comment, and JV time and link. The reason I have a core, and because I'm actually reusing this code from homework assignment number 3. So because person inherit from core, that's why I also have a core. But I really designed for this is just all this class. You can see that I put every pigeon into every pigeonhole. Every first level, I put everything into that. Is that answer your question, Nathaniel?
Yes, it does.
Okay.
Thank you.
Thank you. Okay, so this is the design. So you now see that what I trying to advise you is how do you actually bridge this two object world together in terms of one-to-one mapping. Then you can have that. So now the question, I think Jenny asked the question earlier is that, well, how do I actually access to each of the value from the key, right? So for example, we have now you see we have 11. And how do I actually access in C++ access to the value? So this is the programming I included. Let me first use my lecture number 10's example, then we're going to see the real code for that, okay? So if you look at my my program, this is an example about how do you handle the reaction. Okay, how do you actually get the reaction? Because I have a key, right? ID is a key, from the key, created time, comment, reaction. How do I get a value of a reaction? I just use, okay, so first, let me see, hold on. Okay, remember this my V, okay? My V, what is my V? My V is similar like this. To tell you what my V is. I have it here. Okay, here. You see that my V is in fact is actually equivalent to this. Is called JSON value my V message, and I parse using the parse variable, put everything into this message. So essentially, you have a string input as a whole JSON. And I actually using this routine parse, which by the way, this part of the program is contained in HW5 parse .cpp, which distributed with the reference implementation. I also distributed earlier as well. But basically, when you call this parse function, it's actually putting all the JSON string into this JSON value. And once you have this myv message or myv, that's just the name I name it, then you can just use it to extract the field. You can just say myv reaction, double quote reaction, and you don't need the count, because the reason I need count is because myv itself is an array. And so that's why the first key is going to reaction, the second key is going to go to the count. That's why is because, let me actually see how I can tell you this part. I have this part of this. Okay, here is a better example. So look at this. This part is representing the reaction from the whole object. So you can see that the reaction is a first level key, reaction. So the reaction itself is an array. It's array over here. That array has two elements. One is data, one is count. So I have a data and a count. Sorry, this is not array. Reaction over here is an object, but array in the JSON has to start with a bracket. So data is array, but reaction is an object with two key value pair. One is data, one is count. So how do I access to the count? Is it reaction and then count? How do I access data? Reaction and data. How about I want to access the whole thing as a JSON value? Then you just say reaction. So that's why you have the code over here. You see that you can say my V reaction, double quote. You can see my V reaction and count. Then you can actually go into that. Okay, so that is a JSON notation. I mean, for example, the other way I want to say example I put it here is like, well, how do I get to the person? Let me actually go back to my example. If you look at this example here, that's why I have this example step by step, tell you how you can use this notation. Okay, but did I tell you this part?
Can I ask a question, Professor?
Sure, Nathaniel, go ahead.
I don't understand what the difference is between the reaction files you gave us and the reaction code that you showed right there on the slide. Yeah, that one.
This piece of code and the reaction. Okay, so the reaction.h that I show you is you see I define a class called reaction, right?
Yes.
So the reaction code I show you is a definition of the class called reaction. And this piece of code is the user or an application of using that reaction definition. So you see, this part is my V is from the JSON world, is from the JSON value. So this is a natural representation about a JSON object. And the reaction is a C++ object. So what I did here is I'm actually putting the JSON value into that reaction object. So you see that at the end, I'm actually creating a JSON object.
So where is this piece of code found? Like in what file?
No, this piece of code, you have to write it yourself.
Oh, and wait, I'm kind of confused on what type of file we would include this in. Would we include this in a reaction class file?
No,
Or
no. This is not going to be your reaction class. Reactions.cpp and reaction.h is basically you have to do that as an implementation of this reaction class. But what you need to have is that right now, by the way, this is again, I'm showing you is about how you can, I'm using an example to show how you can follow this 5 steps. This 5 steps, okay? And this step that I'm going to show you the code is actually step number 3. So step number 3 is putting the parse JSON into the C++ object. So essentially, if you think about your program, is that you have to, this is going to be separate program. We have about 11 files or 10 files you design for C++ class, right? And now you need to write a separate CPP program, which actually include step 1, step 3, and step 5. Which this is the program is really reading the JSON, and then to utilize the things you develop in step 2, and then to basically parse the JSON file you just get in and shuffle the data you get out into each of the C++ class. That's what we call you convert a JSON into a C++ world, C++ class. And then after you put it in, then you want to reverse the process. That's the last step you're trying to do. So the whole example, you don't have to follow my code because it's just using a program using a C++ to tell you what you're supposed to. I'm just basically using code to express that how you might be able to do that, but you don't have to follow exactly this, let me actually tell you that the difference between requirement and reference implementation. So when I say reference implementation, I'm just telling you that I give you information. This is possible way for you to realize the requirement. But the real requirement that we have is just simply saying that, hey, I give you a JSON. And this JSON need to have this element of classes that you need to represent in C++. And you design those class and put the JSON into each of the class. And from this class, you reproduce the JSON. The requirement is that the produced JSON need to be the same as the input JSON. That's the requirement. If you can fulfill that requirement and you have the class response, we don't force you to do whatever way that we're doing in the reference implementation. Okay, I just want to clarify that. This is not the required. That's just a way for me to convey that potentially this code might help you to develop your thinking about how do you construct the code. Is that clear, or that's not still Nathaniel? You need me to explain more.
I kind of understand it.
Mm-hmm. Okay, so I was in the middle of conveying still that in order. So what I did in this presentation, I realized that I should tell you what I my intention is in this particular lecture, is that I want to give you a variety of tools that you need to know. That, for example, how do you look at the JSON? How do you actually write program to extract things from JSON using the JSON CPP library? And I'm actually lecturing all the tool you might need to use, but exactly how you're going to put this tool together to fulfill that requirement is your freedom that you can actually develop that. And I think that way you can learn as well. To see, not just say, oh, I give you 5 tools, you have to use all 5 tools. No, you don't have to. You can just use 1 or 2, and the TA and the instructor will help you in the process when you try to use the tool, and it seems to me you cannot get the result you want, or you actually didn't understand the tool. That's when we can help you to provide. So we don't want to mandate, but we kind of like the help system to actually, when you're using the tool or when you try to build a concept, you have any trouble, we try to help you. I think that is better for you to learn the whole process. Okay, that's the design. So I want to, oh, go ahead, Nathaniel.
So basically the required of what we're supposed to do for homework 5 is read the JSON and separate the different things into classes,
Mm-hmm.
and then create a new JSON.
Mhm.
from those classes?
Mhm.
Okay, I just wanted to get that.
And then that JSON to verify if you did the right thing, that JSON should be the same as original JSON.
Oh, okay, I get it.
Yeah, that's why I show earlier in this video that you use a difference command to see the input and the output. They're exactly the same. If
Okay,
they're the same, that means you're doing the right thing.
yeah, I just didn't understand like what we were actually supposed to be doing in this homework assignment, like what the main outcome was.
Yeah, the main outcome is a requirement to generate the JSON, this matching the input JSON from this
Okay,
process. But you do need to you do need to create classes and shuffle it in. That's what I call pigeonhole. You have to put all the different pigeon into different pigeonhole. Yeah,
okay, thank you.
you're welcome. Okay, so I want to go back to that. How do you extract the um, the field? For example, let me give another example which I didn't have in this original one, but I want to use this as an example. So you see that this is the reaction. So we're looking at the reaction. So reaction has one of the element, which is this is really a reaction. And the reaction has multiple key value pair. The first one is avatar name. The second one is a VSID. And then they have a type, they have a created time, right? So how do I actually access to each of the field, like a avatar name or VSID or type or created time? Let's see how I did it in this code. So in this code, how do I access okay, number one, you can see that I said, because the reactions, under reaction, we have a count and data. That's why you have a reaction count, reaction data. But reaction data is an array. That's why you have to say reaction data I, array, because this part is the name of array. Remember I said reaction data is an array. So that's why reaction data is an array, then you can put the array index. And so what I did is that I put a loop through every single element in the array, and I just name it differently, say my reaction data I assigned to LJV. And I said that in the lecture that these two are actually the same. You can say LJV avatar name because LJV is the array and element, that element array. Or I can say my V reaction data I avatar name. These two will be exactly the same. So when I say LJV avatar name, it's getting me this value. Sorry, L reaction data and then avatar name is going to give me Peter in this case. Okay, so you're using, I mean, I think the question was, well, how do I get the each of the element from the JSON value, which is a JSON CPP library? You just using a sequence of key. If it's array, then you put the index there, and then this part, just let me actually copy it so I can actually show that correctly. So in this example, this part from here all the way to here, you actually will get a JSON value object. So you basically give one key or a sequence of key plus the array index. This will give you that JSON value that's actually at the other side of the column from a key value pair. So the type about this part, I just mark it highlighted here, is actually itself is a JSON column value object. And then because I know this particular avatar name is a string, so that's why I call this function called sString. Using this JSON value and dot sString, then this will return me a string value for that particular object. So you can have as string or something you can have as int or as a bool, as whatever. So that interface is basically a JSON value, and then you call as double, as string, as int, as whatever, it will automatically convert that JSON value object into a type that's matching a string type or integer type or Boolean type. And that's the interface for you to handle the JSON CPP. Is that somewhat understandable now about how you can actually get using the JSON value or JSON CPP library to bring this information into your C++?
So should we do this for every single piece of content, like the message and the person, in one file?
Yes,
So,
you have to do every pieces
mhm.
in this file. Let me actually show it to you. Essentially, you need to do for this 11, right?
Yeah.
The first one, I mean, after you parse, is called my v. Then you have to do my v, double quote ID, and then my v, double quote from, double quote, and my v2, right? You can do this. I just want to show you very quickly to take a pic of that. Let me start recording. I don't want to give a recording. Hold on. I know what I want to do. I want to stop the stop sharing, but I'm still recording. Hold on 1 second because I want to do some editing. Okay. I want to do some editing. Give me a few seconds. Okay, I think this is good enough. Okay, I'm going to share the screen now. Okay, so just show you that this is again, this is just a reference implementation. I basically remove some of the code from the HW file produced and just tell you that what it looks like. So at the beginning is just this is the program of how I'm going to put this together. The beginning is just reading the file, right? I'm just reading that JSON file into, this is the code I explained the other day, and basically just take it in. And then this part is parsing that JSON. So at this moment, this piece of code is just parsing that JSON using this reader parser function to parse that JSON. So now at this moment, after I finish this piece of code, I convert that string format of JSON into the JSON colon value object. Okay, by the way, the code up to this point is already identical to HW5 parse.cpp. This is identical. Okay, so now what I did next is I actually create a post. Remember, I have to create the highest level object. So that's why I have a post. I create this post object, my post. And this object create because I only need to create one, and this object is going to represent that JSON, right? And now I'm actually going to parse each of the element, 11 element. I'm going to show you the first 3 elements, how I do this with some redacted. So the first element I need to do is action. So what I did is that I actually check whether you do have action. So I send my v message action count if this is greater than 0. So you can see that because action is an array, if it's a count is a 0, I don't need to even handle this at all because that's what I did. So once I handle this part, remember my v message is the message I actually parse. Okay, my v is the JSON value. So I use action to actually get the value of our action. And then within this action, I basically have a loop to go through each of the action. And again, I'm using count as the loop. So I'm actually, the outside loop, I'm going to check whether I have this attribute. The inside, I just using a loop to do that. Okay, the next one is, okay, very important. At the end, after I've done all of this, I actually say, you see that I do, here is my post. Here is my post. I actually say my post dot action, which is the attribute I have. I'm actually putting this vec action. What is a vec action? Vec action is a vector of action function I define. So essentially what I did is I know I'm expecting a vector of action I need to handle. So I go through the loop to actually put each of the element into that action object. And at the end, I put the whole action vector into my post. So here is I'm putting the vec action into the post, the action attribute under the post, and then I basically fulfill this part. And similar, I have comments. And over here, I have a comment, I have a reaction, I have a tag, but this part is really the comment because the reaction here is not a reaction to the post, it's a reaction to the comments. And the tag is also not tagged to the post, the tag is to the comment, but the important thing is about the comments. So I check whether you have any comments. If you don't have any comment, I'm not going to do this part. But if you have a comment, then I have a loop with this. And you can see that within the loop, I actually handle the reaction part. This part is the reaction part for the comments, and therefore I put the vec C reaction pointer, which I defined here, inside the comment, there is something called reaction as well. And also I did the same thing for text. And after I put everything into the comment pointer, which is represent this, and then what I did, eventually I'm going to do my post.comment is equal to vec comments. Again, I'm actually putting I parse everything within the comment portion about my JSON. And then after I've done this, I actually put it into my post. So you can see that every step I'm actually doing one element after element. At the end of each element, I always put it into the post. Okay, so that's pretty much the code is going to do. You can imagine I have about 11 sections of such code, and each of this is putting into element. And eventually, what you will have is, that's why at the end, you will see my last part of the code looks like, hold on 1 second, do I have that piece of code here? I didn't have, yeah, this is a piece of code also like this, right? My post reaction is equal to vec reaction. So that's kind of the code we're looking at. So eventually, after you've done all this, so you're shuffling all the object into the post object, and then you can just call my post.dumpj. You're going to get everything back to the JSON value. Any question?
Basically, after you got the content from the JSON into the C++, to get it into the correct location, like the correct variable, you just use the reference?
Yeah,
And
I
then,
use reference.
okay,
Yeah,
so you didn't do anything, you didn't set anything as a static variable, you just use pointers?
okay. There's a different way. I mean, I don't want to mess up with the static variable, and because static variable in C++ means somewhat a little bit different. So there are two kind of variable. One is dynamically allocate. The other one is statically allocate. So static allocate could be local variable. And so this is just my implementation. You don't have to do the same thing. I use dynamic allocation, memory allocation. But it's your choice to say whether you want to use new or you just want to create object yourself. I mean, dynamic memory allocation is probably more appropriate for this case. The reason I said that is because I don't know how big my JSON is. So therefore, I want to control the amount of memory, because I mean, the example I gave you is pretty small. The JSON is kind of small. So if your code can handle that small JSON, that's fine. That will be good for homework assignment number 5. But when you really build a real system, that the JSON typically is going to be I would say much bigger than the JSON that I send it to you to process, and therefore you need to be more sensitive to your memory management, and that's why I use dynamic memory allocation in my example, but you don't have to.
Professor,
Yes.
could you clarify what pushback is doing?
So pushback is a member function for the vector template. So pushback is sending the element to the end of the vector. You can think about the vector as like a queue.
So
you
is it just appending it to the end?
Yes,
Okay.
appending to the end. Yeah, exactly. Yeah, pushback is appending to the end. Yeah, you're exactly right. That's a better way to say it.
Um, I have a question. I don't know if you've gone over it yet, or but what is the main file that is going to be actually taking out the different parts of the JSON and putting them into the classes and everything, defining them
Yeah.
into classes?
In my implementation, this is the file, the hw5 produce.cpp. That this
The
file,
HW5 parse, or
no, hw5 produce.
oh, and we have
HW,
to create that.
yeah, you have to write your own file, but you could use hw5 parse, because my hw5 produce, the first like a 40 line, they were identical to hw5 parse. So let me actually tell you what's the difference between hw5 parse and the code you need to write. So the first part, this part I'm showing you on my screen, this is exactly the same as hw5 parse. The parse part, the first part is basically just taking the file, reading the file into your memory. That I'm showing this part is just reading the file into the memory, okay? And then after you finish reading the memory, you need to do the parsing. So this part is the parsing. So essentially your HW5 parse will stop here. It just parse the file,
Yeah.
make sure it doesn't have any error, move on, right? But now with the homework assignment number 5, this is the beginning. You need to add other thing after this point. So you should add your code after this.
Okay. And those codes would practically just be implementing the different classes, right? And structuring.
Using calling those classes. So you already create those classes .h and .cpp separately. Over here, you just pulled out each of the key value from your JSON value object, and then create corresponding C++ object and put that value into those objects.
Okay. In that part you just highlighted, where did you reference to pull, or which header file did you reference?
Oh, for example, if I have action, right, I have to reference action .h, right?
That's how you reference it?
Right. I have to. No,
Okay.
well, I have to say that at the beginning.
Oh yeah.
I didn't. I have a link and post. But by the way, the reason I don't need to include everything, because if I include post.h, post.h basically has everybody. Post.h actually include everybody else.
So
So
all
I
you would really have to do is just include post H. You don't
just
have to include
include
the other one.
posts. Right. Exactly. Exactly.
Okay.
Because posts really have all the elements, right? Post has
Mhm.
action, has link, has reaction, has comment. So
Would the sorry.
yeah, I just want to say, so the post is something which I said you should first design posts, because posts really include everything. If you finish the post, you kind of know what you have in the JSON, right? And then the HW5 produce.cpp is just following that flow of information. You pull information out from the JSON and then put into the class post and the subclasses from the post. Hey, Belinda, what?
My question was, would the Homework 5 produce program also create the new JSON? Or would that be another program?
I actually just create. I just use the same program
Okay.
to create the JSON, because you shouldn't have another program, because the C++ object is all in the memory.
Okay.
So therefore, we're not touching the other topic, which is I hope I have time to cover. It's called persistent object. Persistent object means that I can create C++ object, but this C++ object is actually going to be stored in the file. So you can actually open the file and bring the object back. Typically, all the program you have done so far, once you kill the program, the object is gone, right? But with that, you can actually really, to keep it alive, even you kill the program, you can just, next time you call the program, that's called persistent object. All the object we have is called transient object. Okay, so that's why, because of that, your printing JSON should be within the same program. Otherwise, the object is gone.
Okay, thank you.
You're welcome.
In that, the file on the piece of code you showed us about reaction, that would belong in homework 5 produce, right? That's like referencing
This
the
piece of
reaction
code?
aspect. Yeah.
Yes, yes. This piece of code is in HW5 produce. Yeah, exactly.
Okay.
Okay,
Could I ask a question about homework 4?
sure. Hold on. Let me stop the recording, and then I will